In the last example, we showed how to take two given functions and show that they are inverses of each other. But how do we take one function and find what its inverse should be? Well, the definition of the inverse of a function tells us that if the function f is the set of ordered pairs x comma y, then the inverse of f is the set of ordered pairs y comma x. If a function is defined by an equation, we can obtain the inverse by switching the variables x and y. The steps to finding an inverse from an equation are: first, for convenience, replace f of x with f. Step 2, interchange x and y. Step 3, solve for y. And then step 4, you now have the inverse, so replace the symbol y with the inverse symbol. Example 3, let's find the inverse of f of x equals 7x minus 5. So step 1, for convenience, think of this as y equals 7x minus 5. And interchange x and y. So instead of y equals, x equals. Instead of 7x, 7y minus 5. Solve this for y. First would be to add 5 to both sides, leaving 7y on the right. And then lastly, divide by 7. So now y is alone, and now that y is alone, you have the inverse. So the inverse of f is x plus 5 over 7. Example 4, we have the function f of x equals x cubed plus 1. So again, the first step, for convenience, think of this as y equals x cubed plus 1. And now interchange x and y. Instead of y equals, x equals y cubed plus 1. Solve this for y. First subtract 1. X minus 1 equals y cubed. And if y cubed equals x minus 1, similar to the square root property, y would equal the cube root of x minus 1. Now that y is alone, this represents the inverse of f. Example 5. We have the function f of x equals 3 over x minus 1. Think of this as y equals 3 over x minus 1. Interchange x and y. And now solve for y. So solving this for y, we have a fraction, and so same strategy we always take. Identify the common denominator, multiply to eliminate the fraction. So since there's only one denominator, the y, we want to multiply both sides of the equation by y. So multiply by y, multiply by y, multiply by y. On the left, when you multiply y and x, all you get is xy. Typically, we write that in alphabetical order, so xy. Yx would also be correct, but again, typically we do alphabetical order. Equals 3 over y times y. The y's would cancel, leaving 3. Minus 1 times y is 1y, or just y. So we now have eliminated the fractions, but now we have 2 y's on our paper. We want to get those y's on the same side of the equation. So we will add y to both sides, eliminating on the right, leaving 3. And on the left, xy plus y, you can't combine those because the x makes them not like terms. So you're forced to leave this as xy plus y. So since there's no way to combine these two terms, the only way to get one y is to use factoring. Since they both have a y, you can factor y out to the front. If you factor y out of xy, you're left with x, plus, if you factor y out of y, you're left with a 1. Our last step to get y alone, since it's being multiplied by x plus 1, we would want to divide by x plus 1. The x plus 1s will cancel. Y is now alone. And so your inverse is 3 over x plus 1. Some problems might also ask you about the domain and range of your function and your inverse. Remember that the domain of your function has to match the range of your inverse, and the domain of your inverse has to match the range of your function. So talking about domain and range, we need to know what the domain of the function is and what the domain of the inverse is. So let's start with the function. For the function, we have 3 over x. If x is 0, we'll be dividing by 0. So the domain of our function is all numbers except x cannot equal 0. For our inverse, I have 3 over x plus 1. If x is negative 1, I'll get negative 1 plus 1 is 0. And so my domain for the inverse is all numbers except x can't equal negative 1. Now for the range. The range of the function must match the domain of the inverse. So the domain of the inverse is that x cannot equal negative 1. That tells me that the range of my function must be the same, and we get that y does not equal negative 1 is the range of the function. Similarly, for the inverse, the range of the inverse must match the domain of the function. The domain of the function is that x cannot equal 0, and so the range must match, and all numbers except y cannot equal 0. Example 6. Find the inverse of the function f of x equals x squared minus 1 if x is greater than or equal to 0. So first, let's talk about why we have this extra component of x being greater than or equal to 0. If we were to graph this function, which we'll talk about in depth in the next section, the graph looks something like this, which does not pass the horizontal line test, and so it's not a one-to-one function. So by saying x has to be greater than or equal to 0, we are essentially only looking at half of the graph. And specifically, we're looking at this half of the graph. So if I look at half the graph only, now we have a one-to-one function, and we can find the inverse. How this will change things for us is at some point we will have to use the square root property. And when we do that, since we're only taking x to be greater than or equal to 0, we'll not use the negative for the square root property. So let's proceed like normal. Y equals x squared minus 1. Interchange x and y. And solve for solve for y. Add 1 to both sides. X plus 1 equals y squared. And if x plus 1 equals y squared, the square root property says that y will equal, typically it says plus and minus the square root of x plus 1. But again, since we're only doing positive x values, we're only going to use the positive square root. So just the square root of x plus 1. So the inverse of x squared minus 1 for x greater than or equal to 0 is the square root of x squared plus 1.